Okay, not seeing much response in the chat. Hope that's a good sign that everyone is working perfectly with pandas. So this week we're going to continue seeing some more demo examples of pandas. If you click the link I provided, you should be able to open up this notebook. You might see a slightly different interface. That's okay, but I think you should be able to execute all the codes directly inside this notebook. This time I'm not using any external data set. And if we click running, you should see the first one shows the demo data set we're using today, which is the California housing data set. Forget about the training. Well, if you want to take a look at it, there is like a bunch of built-in data sets here you can kind of use. You don't need to worry about training versus testing for now until maybe you're in Python 200. That's for machine learning purposes. But anyway, this data set contains about 17,000 different data points where you have the longitude, latitude, the median of like different regions in California or different houses in California, their like housing median age, their number of rooms, their number of bedroom, total population, household, and so on and so forth. So that's a much larger data set than the iris data set we've seen last week. And today we're going to see how can we work with data across this one. Okay, so a little bit of continuing from last week. Last week we see, okay, we can do some data manipulation, like if you plus one number to for example, if you select, okay, let me just type here. If you do like df of, let's say, latitude is equal to df of latitude plus 1, then you will convert, like, for example, the first row will be 35, the second row will be 35.40, the next one will be 34.69. You will do a plus 1 operation to the entire series, to the entire column, provided that you have the right data type. I believe this will not, well, this will work for now, but I don't want to temper my data set for now. This is just showing you. Okay, I can call df2. Well, this one wouldn't work because df2 is not defined yet. Anyway, let me just do it this way. A little bit of refresher from last week. You should see, okay, it's actually plusing 1 to anything. So you can do most of the mathematic operations you have here, and you can also do some custom functions like something. But sometimes you may run into a problem like, oh, if you're, instead of using one column, you're selecting 2 columns, then you'll run into error because what are you trying to do? Python doesn't really get it. That's okay. You'll learn some other techniques maybe in the future to work with. What if you have a multi-dimensional or you want to work with multiple columns at the same time? And today we're actually going to see some of that. So today the first section today, we're going to see 4 primary operations for data selection. First is the location, locate, log, or however you would like to read it. The second one is index log or ilog, basically selecting row and column by integer precision. You're basically treating your Python data, or your pandas data frame as a list in that type of filling, as we mentioned last time. And you can also use the index slicing logic for multi-dimensional array, not just for one array. What does that mean? That means whatever you have done before about array, about vector, it's list. For a list, you can do it directly with your series or data frame in Python, in pandas. So let's see this example. This demo will select an index log location from the 0 to 5th row, comma. The first one is specifying the row. The second one is specifying the columns. So as you can see here in the execution, I got a 5-row by 2-column data set from 0 to 5, from 0 to 2. And this is exactly what I'm looking for. Similarly, you can also chain your index location and location operation together. For example, if you select this first operation, will select the longitude series from the data frame, and this ilog will select the first 2 rows of that. And similarly, you can kind of skip the ilog because if you already know, okay, this is going to be an array. This is going to be like a pandas series. I don't really need to do that, right? So I can just specify the first 2 rows. Both of them are acceptable. So at this stage, you have multiple different ways to work with pandas data frame. If you look into the reference, you'll say, oh, some of them has better performance, some of them do have like worse performance than other. But for, let's say, for majority of our like homework or tasks, like 99% of the time, it doesn't matter. I'll put it here. I also write it up somewhere in a notebook. Anyway, another 2 operations. So location, index location are primarily for selecting the series you want, and they're a little bit more flexible than other ones. You can use location indexing and indexing location for like selecting just a single element, selecting multiple different elements, selecting an entire data frame, creating a sub data frame. So there's a lot of things you can do, work with them. And it's kind of a pop quiz, it's not included here. So when I'm using this thing, you may wonder, okay, then how is it different from, can I also chain it with other operations we have seen? Like, for example, let's say longitude is greater than 2. Well, I think you can already guess. The answer is yes. You will see a user warning because this is not a recommended approach, but technically speaking, yes, you could. Now, can anyone tell me, this is kind of a reminder, can I use and when I'm slicing this? What if I want to specify like location? Okay, now I have this sublocation. I only want to select based on the certain criteria. Can I use and? Correct. You have to use something that looks like C++. You're not using and, or you're using kind of, in Python, this is called the bit operator, the bit and bit or. Okay, when you're doing logical selection. That's a major difference in syntax with pure Python. You will need to use and, or, and other operators. In terms of, put it this way, you need to use the bit operator for your Boolean logic in pandas. Cool. And now we also have at and index at, which is used to basically access a specific cell by label and by position. I do have a demo here. Yes. So you can get the median house value by this one will specify, okay, this is the first row. You specify the row first and the column you're interested in seeing. This one will tell you the median house value. And if I want to switch that to something like, let's say, what is the good example? Okay, total bedrooms. Why not? This one will now no longer put out 66,900. This one will now print out something like 1,000 or something. And notice that this operation is exactly the same as the second one. I mean, I can specify the column first and then use this, right? It's equivalent in that sense. Whichever you would like to use is best. Personally, I like to use this one because I don't have to type at. It's kind of a lazy thing, but yeah. And similar thing would work for index at. In principle, index at is not used very commonly because all the things you could do with index at could be done with index lock. So Any question so far for selecting something? So the real power of this thing, this operation, like ilog, log, and like, is to really combine them with the filter operation, like the one we've seen last week, like selecting the columns and so on and so forth, like selecting some of the values based on the condition. Now you have a powerful tool set to run some analytics on your data set. And we're going to see some quick example. But before that, let's do a quick concept check. So this is just to reinforce what I just said. There is some minor performance issue. I believe using like index location, like selecting based on index will be faster than based on like the columns. But unless you're working with a really large data set, that difference is minimal. And there are more critical performance bottleneck in pandas than like the indexing versus non-indexing selection. So I don't think that's something you need to worry about extremely. Most of the time, that's not a concern in performance. So just go with whichever way you would like to do. As long as you complete the task in time, that's a good strategy. Okay, now we have a quick concept check question. So remember, our original data frame has 17,000 rows and 9 columns, right? Now, if I do this index location with demo, I'm setting demo into index location of this thing. Remember, this is then the first one will specify the row, the second one will specify the column based on the Python indexing logic. So, what would be the shape of this demo data frame? If I type demo.shape, what would be the shape of it? Type your response in the chat. I'll give everyone a couple of minutes to think. For example, I have this. So what if I set demo this one? What would be my demo.shape? Can anyone tell me? Type your response in the chat. Okay, I see one answer, B. Anyone else? Does everyone agree it's B? Anyone? Okay, raise your hand in Zoom if you think the answer is B. Or just type +1 for agreeing that's B. Or everyone think it's something else. Anyone? We all agree it's B, +1. We have another approval. Okay. Unfortunately, it's not B, it's A. So remember, in pandas, the first column is going to specify the row. So if I have, let's say, nums, this is a reminder of, let's see if I print nums of this, I'm going to print the entire thing. So I'm not truncating any rows here. But this is required, unfortunately. If I delete that, I'll get a syntax error. Believe it or not. Invalid syntax because I'm not specifying the start and end location. This is equivalent of, well, it's not supposed to be -1. It's just, this one is the best one. It's equivalent to saying this. But remember, if you do not tell the specifier, okay, what is the starting and end, then we'll parse the entire list. So this part is telling Python that, okay, this demo is going to contain every single rows from df. Are we cool with that? So I have 70,000 rows just as in the original data frame. Now, the second one is going to tell you the columns. Okay, I'm starting from the 0th column to the 5th column and stopping at the 5th column, or stopping before the 5th column, right? 0, 1, 2, 3, 4. So that is going to be the demo dataset. And if I print out the demo, you should see that it has 17,000 rows and 5 rows, and that's exactly the 5 columns, and that's exactly the first 5 columns in the data frame. Remember, index is not a column. It's not a column per se, or a panda. So maybe, well, it's kind of a column, right? If you print it out, if you download this data frame into a spreadsheet, it will be a column. That's the indexing column. That's not a serious column. That's some distinction we have to make here. Okay? Everyone cool with that? All right, let's move on to the next section. Before that, any questions so far? Nope. Okay. Now the next section we're going to see is the data aggregation, which is a little bit more sophisticated than the previous one. And you can do a lot more interesting stuff with it. So far we have seen how to interact with pandas by reading data, selecting data, and do some simple data manipulation. But what if we want to really do something that's more complicated? For example, we can do like +1, we can do multiplication, we can add in some numbers, we can like find the standard deviation, find the, let's say, mean, the average value. But what if I want some costume operation? For example, I'm interested, well, this is maybe too statistical, but I might want to know what is the z statistics of something. Maybe that's not built in. What can I do with that? Well, fortunately, pandas and a lot of scientists, data scientists, have thought about this problem, and we worked out a solution very well. One of the methods you could use is called the apply. So here I am defining a costume function, affordability, which will take in one of the value and evaluate whether it's smaller than the 25 percentile score. Well, for those of you who may not or forget about what is 25 percentile score, 25 percentile score, it means that, okay, if you have 100 people, then you're at number 25 in terms of ranking. And 50 percentile score, which is the median, means that, okay, you're just in the center. You're better than half of the people, worse than half of the people. 75 percentile score means, okay, you're better than 75% of the people, depending on the sorting. Okay, so here I'm just using a simple sorting method. If you're below the 25, if the median house value is, if the value is below the 25 percentile, which means that you're in the bottom quarter, you're affordable house. And if you're somewhere larger than the 75%, means that, okay, you're the top 25% most expensive houses is unaffordable. The rest of them will be put into medium affordable. I know this is not the best metric we could get, but this is just demonstrating. Now I can add an additional column called affordability, which is based on the median house value. And I'm applying this affordability function to every single column, every single row here. So the median house value is 66,000. I don't really know what is the 25 percentile score. Well, I can scroll up. That is something you can see in df.describe. So the median house value, where is the median? It's getting too large. 25% is, whoa, 11. I think this data is outdated. I don't think the median is only like 180,000 these days. But anyway, that is the median house value based on this data set. This data set is probably from more than 10 years ago. If you want to later newer version, you can find it somewhere online. So that is based on those numbers we have seen above. I can pull it up here. Let me do it. Okay. So I have this housing value here. So if it's smaller than that threshold, it's affordable. And if it's larger than that threshold, well, I haven't, most of these first 5 rows are all affordable. Anyway, now notice one thing. If you actually execute this on your computer or on this Colab notebook, this might be the longest operation you're ever going to see in a while for a couple reasons. First, this is a larger data set. Well, you have 70,000 rows. And second, this apply is a row-based operation, which means that it's kind of like a for loop that you will have to parse each of the row by row. It's going to go through, okay, the first row, affordable, second row, affordable, third row, affordable, fourth row, affordable, and so on and so forth. Whereas some of the operations, for example, df is equal to df of, let's say median house value plus 1,000, this is considered a vector operation, which means that you are doing something directly onto the entire vector. And in pandas, there is a significant performance difference in the two operations. So if you're really, really, really concerned about performance, another way, this is something that we call a vectorized operation. You will need to create, okay, a masking array for this series and say, okay, this is masking array and this is something and something and something. You might need to use like an MP select to do that. That will go faster. There is some way to run this operation faster. On my Colab notebook, this is running for 10 seconds. I have some apply operation that runs like 5 minutes or 30 minutes before that I was seriously thinking maybe pandas is not a go-to option anymore. So that is one performance bottleneck you might need to worry about in future. So be cautious when you're using apply. And also notice that technically speaking, I can also call a lambda function to do the same job. As long as it's a function here, I can do it this way. But for readability's sake, I'm not a fan of more than one line of lambda. Like if it's, my rule of thumb is that, okay, if I can finish something in one line, then I'll use lambda. If I can't, I'll just write a function and call it here with apply. Now, any questions so far? I was going to pause a second to see if anyone has a question. Feel free to take your mic or just type in the chat. Nothing? Cool. Now, next thing we're going to see is to run some more analysis on the affordability of the houses based on the categories we just created. Now in DF2, we have this affordable, unaffordable, and medium affordable columns. And it's a common technique for data analysts or data scientists to run some segregated analysis or like some analytics based on segregation. Like let's say, this is a common technique, right? You're comparing, okay, let's say, is there a significant difference between like the SAT score of kids born in 2000 versus SAT score of kids born after 2000? Is there like a significant difference in like college admission before COVID or after COVID? Or is there any like academic different performance difference or something, housing price difference before COVID or after COVID? Something like that. What if we want to run something like that? Well, let's try to give it a try. So here, I'm also demonstrating what I'm trying to do is a group by operation. So I'm trying to group each of the median value, house value, housing, median age, total number of bedrooms, and the median income, and calculate their sum, their mean, and their count. How many counts are there? And I can do this by this following, but there is some common syntax error I'm trying to demonstrate in this try and except block. But first, I want to demonstrate one technique. When you start working with Panda, you realize, oh, hold on. In some cases, I'm going to run some code like that's more than one line long. And we all know it's not a good practice to have like, well, we used to call it the 80 character practice. If your code is longer than 80 characters, you probably should break it into 2 different lines, like this, kind of. I think it's not necessary here. I'm not a huge, well, 80 character was designed in like 1970s, so it doesn't really work that well these days. But what if you want to have more than one line? Well, in Python and Pandas, you can use this technique. If you add a bracket, this whole thing will be considered in a line. And you can also use something like a slash operator, but I'm not a huge fan of the slash operator because you have, for each single line, you need a slash. But here, this line, if I remove this one, this will fail because, well, I'm not calling everything in a single line. But if I add a bracket around, that will fix the problem. That's the first thing I want to demonstrate here. Second thing is, there is a bug here. Can anyone tell me, like, if I run this, so what's happening here is that, okay, my Python is trying this block, but it has a value error, cannot subset column with tuple with more than one element. Use a list instead. And then this is executing the correct version. Well, you may say, oh, hold on, what's the difference between the correct version and the wrong version? I'll tell you the difference. The difference is there is a square bracket around this thing. But why does that even matter? Why does that even matter? Anyone? This is actually a very common error in Pandas. Why does that even matter? I mean, does this matter? Well, let me first ask you this question. Can I do this? I will need to copy this. Why does that even matter? Okay, so first, can I do this? Is this a valid operation in Pandas? Yes? No? Is this operation valid? Type yes or no in chat. Yes? No? Question mark? Not sure. Is it valid? Is it not? Let's see. It's not valid. Why? I mean, isn't this look something like selecting like these columns? Well, technically yes, but when you're actually selecting all these columns, you will need to add an additional bracket around. Otherwise, because for pandas, if you're enclosing something like this, they will internally interpret that as a lock operation. So this, if you only have a single bracket, you can only select one column. In order to select more than 2 columns, you will need to do this. And now this is selecting these 4 columns from the data frame df2. And for the same reason here, if you only have 1 column here, so this is a little bit on the deeper side, but the execution logic is that for this function is that, okay, pandas is going to select these 4 columns as a sub-data frame, as a newer data frame, and call this affordability group by function something. But intrinsically, you need to provide the right columns. Okay. The reason that this line failed is the same reason as the previous, oh, I shouldn't have deleted that, the previous example failed. Because here, you're only allowed to, if you're only having one square bracket, you're only allowed to select one column. So here, adding an additional square bracket can prevent that. It is also a common practice to just put everything you want here into columns. Oops. And then run it this way. Okay, this is a very, very, very common pandas error. You're missing a square bracket. And if you just, and the reason I'm bringing this out is because, well, it's sometimes it's because of the same problem, but the error message you see is different. For example, if I run this, let's compare the error message again. They fail for the same reason, but the error message you got is different. And it's very, very annoying. It took me like, when I was first into pandas and so everything, this is one of the most common error that frustrates me. Like, hold on, why does it not work? And you look at the code like, no, there's nothing wrong with my group by syntax. Then what's wrong? You saw this group by is not working because this error. What does that mean to have column tuple with more than one element? I'm not using tuple at all. Well, that's the real reason is because you're not selecting the right columns. Okay? Okay, so let's break this down even further. So if you go to the syntax look or the materials for week 5, you'll see some demonstrations like pseudocode for the syntax. But basically, after the group by, you need to select the number of the columns you need. And also the data type matters here. Okay, if I have like, let's say, all of the things here are numeric data types, so it's fine here. But if you don't have something, well, put it this way, you can calculate the average value of, let's say, human and banana. So if you have like student ID or like human, banana, fish, lion as your species column, and you're calculating the mean of that, you will get an error. And here in the .add function, you can have your like the built-in aggregation function, however many you want. I can also add something like for example, previously I have this affordability, right? I can also have this affordability here, as long as it's defined somewhere in the functional scope. Oops. I guess I can't really run this affordability function here because this function will, some of the columns will not work well for this function. But these are the common ones, and you can design your custom functions here. Okay, and once you have the result, you'll say, okay, the affordable, the sum is this one, and the mean housing price for affordable housing is 86,000 something, and for the something, and the median age for affordable house is 28 years. For unaffordable houses, actually older than the affordable houses and other houses. That's interesting. And let's see the total number of bedrooms. I don't know why do they have total number of bedrooms. I guess we should probably make it into like average number of bedrooms, but okay, whatever. And the median income, as expected, for those who can afford unaffordable houses, they have higher median incomes. Okay, so now we have our aggregated pivot table. Well, we call this thing pivot because it really starts from Excel. There's something called Excel pivot table. If you have used that before, you know, okay, it's actually kind of similar operations. You select the numeric rows you want to calculate. You select your pivot, and you select the aggregate functions you want. It's kind of the same thing here. So, any questions so far? In addition to the common pitfalls. Everyone cool with this? Okay. In principle, I would also say that if you have multiple columns you really want to do a group by, or you want to select multiple columns, specifying the column as a new variable will be helpful because, well, let's compare the two. No one likes to read this chunky code. It's a lot easier to understand it this way. This one is more readable, other than like the syntax error that's intentional. This one is a lot more readable than the first version. Okay. Now we're going on to the last section of today's demo, the merge and join. Well, I would say merge is a lot more common than join, so we will probably work with 90% of your work cases in merge, not join, for several reasons we're going to see. Okay, let's say now that we have this affordable versus non-affordable data frame in DF2, okay, but this is not like self-obvious for the reader. How am I supposed to know if I have access to this data? How am I supposed to know what does affordable mean? What does medium affordable mean? What does unaffordable mean? Well, this is where we might be able to use join. Oh, sorry, it's called join in SQL, which we're going to see. We can use merge to finish this. How can we do that? Well, first, we're defining a dictionary, kind of. Well, this is a data frame. Affordability, and a description. So, I think I have this. So I have this affordability info. Affordable is 3 row by 2 columns. Super easy data frame. Why do I need to create that? Well, because now I want to add a description to every single affordability lines here. And how df.merge works is that, okay, you specify, this is what we call one of the data frame is called the left data frame, the other one is called the right data frame. And let's say you have will specify the columns you're going to merge based on the condition. For example, on is currently set to affordability, and okay, great. Affordability exists in both columns, so I can do this on. If I switch this to median income, this will not work immediately. Why? Because median income only exists in one of the columns. You're not supposed to merge on something that does not exist in a different one. It's weird. So, and how is left means that you're doing a left join. I do have a table for left join versus right join versus outer join here. So basically speaking, this doesn't really matter here because for our data sets, everything is there. But for some data set, you might have some null values. Okay, what if there's something that does not have affordability and you're still calling this join? The behavior is not defined. So that's why we have left join, right joins, and full outer join. Basically, put it in an easier sense, it means the left join, right join, and full outer join means that, okay, when there is missing data, what should I reference to? What should I merge my result based on? The left join will say, okay, just use whatever is there in the left. As long as something is there in the left table, then go with the left table. If there's something that's there in the right table, well, but that's not in the left table, then forget about it. So this operation will also change the for our purpose, it doesn't really matter because everything is there. Like everything exists in both tables. But when in cases when there's something that's not there in both table, your left join, your right join, and your inner join would matter a lot. But here we're just saying, okay, it's affordable. Okay, I'm going to reference this affordability table, and yes, affordable. Okay, I'm going to write a description here and match the description as my new column. Does that make sense? Same for the right table here, because here it doesn't really matter even if I'm using inner. But let's say I add something called blah, 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 description, comma, blah, 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 blah. I think this will create something that's different. Okay, need to change into right. No, this doesn't really make a difference because okay. Okay, now I can do df2. Let's say I want to. This is for illustrative purposes. df2 of affordability of 0 is equal to, let's say, blah, 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 blah. And now using inner join, you will see an error, kind of an error. Why? Because you'll see this join actually failed. Why? Because, well, there's nothing like this weird stuff in this affordability info table, right? It's not there. This is not a valid availability. So Pandas is telling me, hold on a second, your join failed because there's something wrong. Well, error message is kind of hard, esoteric to understand. But basically speaking, that's because you have something wrong. But in this case, your left join will still work. Why? Because it says, okay, if there's something unexpected, go with the left table. And if there's no description, then just let it be blank. Notice the difference here. This is actually a very common data error for data analyst, data engineer, and data scientist. Whether or not you understand the difference between right, inner, and left join could be it's a very common interview question, put it that way. Okay, and if you go with right join, I think this one will also give you the join result because it says, well, if there's nothing there, then just go with that. And notice which one is set as the left table and which one is set as the right table. Now, notice that the first row is actually disappear because it's not in the right table, so it will just disappear. The left table is going to be this, whichever you start with the merge, and the right table is going to be this one. Okay, so let's put it back into left to just demonstrate this thing. Okay. The same logic for left join, right join, and inner join would also work with SQL, which we're going to see shortly in a few weeks. This is something you also have to specify when you're writing your SQL queries. Any questions so far for this merge operation? Nope. Okay. To reiterate again, left join means that you're going to, if there's something unexpected, you're going to go with the left table. Right join means that, okay, if there's something unexpected, you're going to go with the right table and ignore the unexpected stuff. Inner join will just crash if there's something that's unexpected. Kind of. It will only work when all of the records are there, existing in both tables. Okay? Okay, now we will go through the final demo, the join example. So here, unfortunately, I have to come up with a fake data for the join. But anyway, we're grouping by the ocean proximity based on the income data and something. We're creating a like an aggregated data frame. Okay. Oh, this one wouldn't work. I don't have this. Ah, this is the wrong syntax. Let's say, well, forget about it. Let's just group by affordability. And now I don't have this ocean proximity. Okay, this one will fail because I'm using the same thing. Okay, hold on a second. Let me correct this. Join df2 is set index median income equals to okay. This one should work. Okay. So comparing, let's go back to a quick comparison here. Merge will combine the data set based on a common column, and join will combine the data frame based on their indices. So that's why we say you're using like merge a lot more commonly than join, because, well, what's the difference? What's the index here? Well, this thing, 0 to 1699. And df2 is here. Well, df does not carry much like information here, right? So you're kind of using, now I'm doing a very bad thing using setting index based on the median income, so I'm resetting the index. But df2, it's supposedly like this, and so does df1. Ouch, I don't have df1, it's called df. Right, from 0 to index to this one. So I'm only like merging based on the index. And yeah, now this set index means that it's going to sort this entire data frame based on median income and create a new index based on that. And left join just the same thing as the merge here. Notice that you can have the left suffix and right suffix here. That, okay, after merging that, you kind of create a copy to the original one. So I'm adding this suffix original to this data frame. That means, okay, these columns come from the first original last data frame, come from df. And these couple guys come from the second data frame. So that is the difference. And in principle, merge is a lot more common than join for whatever reason. We should be able to understand because, well, usually your index does not carry much information. Unless you set it into multi-indexing with value-based index. So this is beyond the scope of this class, but you can set one of the columns as your index, and it's actually common for time series analysis. For example, I can set, this is not a good data set to set this, but I can set, like, create a new series based on a value-based index and do index location and like ilog and all those operations and join with that. But that's not a recommended approach for multiple reasons. And I guess I'm not going to confuse you guys with that for now, but feel free to Google like value-based index. That is something you can do. Feel free to check out this page. I think there's some older demo I have. I can't really find it anyway. But anyway, that is okay. Forget about value based index. You probably won't really need to study that until you see someone work with that. But I think it's not a common practice these days. Anyway, I think that's most of the demo for the day. Thanks for coming, and please feel free to let me know if you have any questions. And if you prefer a one-on-one session, feel free to also just book like my one-on-one sessions. I'll mostly be available in the afternoons for the weekdays. And yeah, I'll hang a bit longer and let me answer some of the questions if you guys have any from homework, from about Python, from other areas. Feel free to let me know. Okay, and in the meantime, enjoy a wonderful rest of your day, and maybe I'll see you guys next week. I'll hang here for a few more minutes. Going to stop recording.